Welcome back to the Math Professors. We cover topics that are in algebra, pre-calculus, statistics, and the calculus sequence. So please consider liking, subscribing, and sharing it. It'll help us grow our channel and provide more free content. So today what I'm going to do is I'm going to cover the mean, the variance, and standard deviation for a binomial probability distribution. So the mean of a binomial probability distribution is going to be n times p. Its variance is going to be n times p times q, and then the standard deviation is going to be the square root of the variance. So what I want to do is I want to talk about a survey of 5 people, and I want to determine the mean, the standard deviation, and then the values that are significantly high and low. So we're going to do this all together. What I'm going to do is talk about what is the numerical random variable. So if I have 5 people in my classroom, I want to determine what's the probability of, say 0 people being left-handed, or 1 person, or 2 people, or 3 people being left-handed. So really what I'm going to do is, it's kind of known that we're going to use the fact that about, and I'm going to say equal to, in this case, 13% of people are left-handed. Okay, so we're going to do our calculations over here because I want to be able to find these probabilities. So since I have 5 students in my class, the number of people that can be left-handed, well, I could have 0 people left-handed in my class. I could have 1 person left-handed. I could have 2 people left-handed. I could have 3. I could have 4, and I could have 5. Now I'm only going to 5 because most of your classes are going to be like 20 to 30 students. So this list can go all the way up to like 20 or 30 students. But let's just assume I have 5 in the class for now, just to make the calculations easier. So what I'm going to have to do is I need to find their probabilities for each one of these particular events. So let's find these probabilities. So with this case, what I know is that n is going to be equal to 5. That's the number of trials. It's the number of students. The probability of them being left-handed is going to be 0.13. The probability of them being right-handed is going to be equal to 1 minus 0.13, which is going to be equal to 0.87. So in this case, we're going to consider left-hand success, and then not left-handed or right-handed failure. So I'm going to have to find p of 0. Well, p of 0 is going to be equal to, well, let's just do the p of x formula again in case you forgot. This is n choose x times p to the x times q to the n minus x. So if I want to find p of 0, well, this is n is going to be 5 choose 0 times the probability of success is 0.13 raised to how many I'm asking, so 0, times the probability of failure, which is 0.87, to the n, which is going to be 5 minus 0. So I'm going to do this calculation, and then we'll figure this out. So what I calculated here is going to be equal to 0.498. I'm just going to do 3 significant figures. So far what I know is this is going to be 0.498. Now the probability of 1. So what we already know is we've already plugged everything into the calculator. So in order to make this thing easier, I really want to figure out what do I have to change here. So when I had 0 here, this is 0, this is 0, this is 0. So the only thing I'm going to have to change are the zeros because n is the same, p is the same, and q is the same. So now if I want to do p of 1, this is going to be 5 choose 1 times 0.13 raised to the 1 times 0.87 raised to the 5 minus 1. So when I go back in here, what I like to do is I like to just hit, if you have a TI, which is required for most people, is if you hit your second enter button, it's going to rewrite all the things, and then you just tab back and turn all those zeros into a 1. So what I get is 0.372. 0.372. So that probability, just 3 sig figs, is 0.372. And then I can do this for 2 as well. And then so on. So I'll pause this and I'll do all the calculations and show you all these. So here are the calculations for the rest of them, just changing your x located, the number in the x spot. And I filled out the table. So really this comes down to today is figuring out the mean is equal to n times p, the variance is equal to npq, and then the standard deviation is going to be the square root of the variance. And what we know is that this is a probability distribution. What's interesting about this is if I add this column, I will get 1. Now I've done a little bit of rounding. It might not be exactly 1, but it's going to be pretty darn close, okay? In order to find the mean and the standard deviation, remember that this is a probability distribution, so in order to find the mean, I just have to do x times p of x. So I will do some of them, and then I'll use the calculator to find the other ones. So I'll do the first couple, and then I'll write down the other answers. So the first one is 0 times this, which is going to be 0, so 0 times p of x. 1 times this p of x is going to be 0.372. 2 times 0.11 is going to be 0.222. And then 3, and then so on. So what I'm going to get is 0.222. This is 0.40499. 0.005. I've done it in my calculator, so I've ran out of the room, and this is going to be 0.00019. Now what's going to happen here is when I add this column, I'm going to do that, I'm using my calculator. What I've done here is on your calculator, what's nice is you can type this in, 0, 1, 2, 3, 4, 5 into L1. You can type these probabilities in, or you can actually go into L1. You can do 5, choose L1, 0.3 up to the L1, 0.87 to the 5 minus L1 up in that, that L2 spot, hit enter, it'll generate all those things for you. The way I generated this column is I went to L3 and I just did L1 times L2 and it just drops those things down. So now I'm going to sum these things up. So stat, calculate, we're going to add up L3, and this gives us the sum of this column is equal to 0.65. That's going to be our mean. So since this is a probability distribution, those are numerical. These will add to 1. X times p of x is going to add to the mean. And then last, what I'm going to have to do is I'm going to have to find the variance. So this is going to be equal to x minus mu squared times p of x. And I'm going to let my calculator do this. So x is going to be L1. My mean is going to be equal to 0.65, and then my p of x is here. So I'm going to go back into my calculator and do that for me. So go over to L4, press up at L4. So now I can put a formula in L4. So parentheses, x, which is my L1 column, minus the mean, which is 0.65, close parentheses, square it, times p of x, which is my L2 column. So second L2, hit enter, and this is going to add all these things up. So what I get is 0. I'm not going to give all the numbers. I'm going to say like 211, 0.0456, 0.2028, 0.0918, 0.0139, and then 0.0007. All right. So I know when I add this column, you're going to get the variance. So sigma squared is going to be the sum of that column. Stat calculate. Let's sum up L4. Second L4. So when I sum L4, I'm going to get 5655. So 0.5655. Okay. What I was trying to show you, and just to verify this, is I want to prove that your mean is actually just this formula, just n times p. And then your variance is going to be the square root of n times p times q. We know that when doing this for a general probability distribution, this is quite tedious. But if it's a binomial distribution, I don't actually have to do this. I already know n. N is 5, p is 0.15. So since I already knew these numbers, I can tell you the mean instantly. So the mean, let's just do it over here. The mean should be equal to n, which is going to be 5, times p, which is 0.13. And what we're going to get is we're going to get this, which is 0.65. Now, the variance is going to be the square root of n times p times q. So n being 5, p being 0.13, q being 0.87. So when that would be the standard deviation. The variance is without the square root. So when I do this, this is going to be equal to 0.5655. So finally, what that means is if I want to find the standard deviation, it's going to be the square root of the variance, which is going to equal we get 0.75, so let's just say 0.8. We'll go 0.75. Now really when it comes to rounding these things, we tend to have to round in terms of x, so you usually get 1 decimal point beyond the given data. So if I was going to tell you the mean in rounding, I'd say that this is 0.7. If I was going to tell you the standard deviation after rounding, I'd tell you this is 0.8. But we don't want to round to the end because I'm also asking for the values that are significantly high and significantly low. So finally, in order to find these things, the values that are significantly high and significantly low, really this will tell me if I have a class of 5, what kind of numbers can I expect? Well, I know there's a 13% chance of being left-handed, and since there's only 5 people, 13% of 5 is going to be 0.65. So, the number of people I'm really expecting is somewhere between 0 and 1. Actually, you can tell that it's a little closer to 1 than it is to 0. So, if I have 5 people, having 1 person left-handed is really not uncommon, or even 0. But really, it's going to be a range of numbers. I'm kind of expecting wherever these probabilities are bigger than 5% should work. So if I want to find significantly low and significantly high, well, significantly low is your mean minus 2 standard deviations. So this is going to be 0.65 minus 2 times 0.75. And then significantly high is going to equal, the mean plus 2 standard deviations. Forgive me for this mess. I'm just out of room with this little board. So this is 0.65 plus 2 times 0.75. So we're going to see the kind of students that we can really expect if you have a class of 5 that are left-handed. So 0.65 minus 2 times 0.75 gives me negative 0.85. I know that negative numbers are not possible, so we're really talking about the values inside this set that are between these two numbers. And then when I add this, plus 0.25, so I'm going to have 2.15, students. So what we can see is the numbers that live in between these things are going to be, 0, 1, and 2. So if I have a class of 5, I can really expect anywhere from 0 to 1 to 2 students. Okay, how this is helpful maybe in the real world. Say I'm a baseball company selling mitts, and I need to know how many left-handed mitts do I need to make. Well, if I'm building for this particular population, what I know is about 13% of the people are going to be left-handed, so I know I can find the mean of that, and I know I can find the standard deviation. So I know that I'm going to sell between, so many people. So the mean's easy. It's just n times your population size for that particular area. So n, which would be the population size for that particular area, times 0.13, and then the standard deviation would be the square root of n times p times q. So that you basically make, again, anywhere between those two numbers. So I have one more example to show you, and then we don't have to go through all this work. I just want to show you this formula and then kind of ignore that stuff. For 100 births in your area for a given week, what are the values of significantly low, high for the number of girls, given the probability that of having a girl is 50%. So really, if I want to find the mean of having a girl is 50%. So really, if I want to find the mean, we know that the mean is going to be equal to, call mu, which is n times p. So n is going to be that 100 births. The probability of girl is going to be 0.5. So this is going to be equal to 50. Now, if I want to find the standard deviation, we know that this is the square root of n, which is 100, times p, which is 0.5, times q, which will also be 0.5. So we know this is going to simplify to 5. So if I want to find significantly low, this is going to be the mean minus 2 standard deviations. So we have 100. That's right. We have the mean, which is 50, minus 2 times standard deviation is 5. And then significantly high is going to be equal to the mean plus 2 standard deviations. So this is going to be equal to 50 plus 2 times 5. So we can see that the number of girls that are expected is going to be anywhere from 40 girls to 60 girls. Now, a lot of times we have to use our intuition to do this. The very first question I might ask a class is, if there's 100 births, how many girls are expected? And they'll, quickly come up with the idea, well, it should be 50 girls. I'm like, well, we know that with statistics, there's always some fluctuation. Sometimes you get a little less, sometimes you get a little more. Well, what would be reasonable within fluctuation? I was like, well, how about like 43 girls? Is that reasonable? Could that happen? And they're like, yeah, that makes sense. And I'm like, well, how about 42? They're like, yeah, maybe 41, 40, maybe. But when I start getting into like the 30s, they start saying, okay, that's probably outside fluctuation. So that's really what these, these usual values or these significantly low and significantly high means. What values are expected within fluctuation. So 95% of the time, if you have 100 births, you're going to get anywhere from 40 to 60 girls. Outside, anything below is going to be significantly lower, an outlier, anything above is going to be significantly high, which means these things are not usually expected. And that's it. So again, consider liking, subscribing, and sharing. Thank you.